Welcome all. In last videos, we have studied about raster scan systems, how it works, what are the types, and what are the main components. In last video, we have seen the display processors and other systems in physical form. In this video, we will learn about the main components of raster scan systems, how it works, and what are their block diagrams, and many more. So let's start our session today. Our topic is raster scan system. What is raster scan system? In last video, you have learned about this. Today, we will learn it. Let's see. The purpose of the display processor is to free the CPU. It means the display processor, all the work which is done in processor, in screen, the CPU is free from that. There is different display processor is available for that purpose. A major task of the display processor is digitizing a picture. It means we have picture and its definitions in pixel form. And as we know, every pixel have some values which is stored in frame buffer. So this is the main task of raster scan systems. We have some major components of this. First of all, scan conversion. We have seen in raster scan system, there is a digitizing process is available to store a picture definition. For this process is called, this digitizing process is called scan conversion. It means scan conversion is nothing. It is a processor is digitizing a picture definition given in an application program. Okay, class. And straight line and other geometric objects. These are our objects: line, rectangle, and others. Next component is cell encoding. Cell encoding is approach can be taken when pixel intensity can change linearly. Another approach to encode the raster as a set of rectangular areas is called cell encoding. As we have learned that all the major operations performed in CG on a rectangular space, rectangular areas. This is called cell encoding. Now let's check this block diagram. This is the architecture of raster scan system. Input output devices is like our mouse, CPU, monitors, different. There is a system bus. We have components CPU. As you are seeing here, CPU is different from display processor. It means CPU is free. All the tasks performed by display processor. There's the system memory, display processor memory. It means this display processor also have memory. Display processor memory, frame buffer. We have learned it in previous videos. Frame buffer and video controller. And this is the monitor. This is the architecture of raster scan system. Draw it in your notebook. Now there is a important topic also. Difference between raster and random scan system. What are the differences between these two? Raster scan and random scan system. In raster scan system, it is well suited for realistic display. It means जो realistic displays available है, it is well suited for that. In random scan systems, it is designed for line drawing applications and cannot display realistic shady scenes. This is for random. Raster scan system, raster display have low resolution than random systems. Random displays have higher resolution than raster system. It means raster systems have low resolutions and random scan systems have higher resolutions. Picture definition is stored in the form of pixel intensity value in raster system, and pixel definition is stored in the form of line drawing algorithm in random system. Number 4, information stored in frame buffer in raster system, and in random information is stored in file system. The example of raster system, home TV set, which is available at our home, and for random pen plotters like printers. These are the examples of random scan system. Now we have learned about this frame buffer. What is this frame buffer? As we have seen in the block diagram, frame buffer is store the pixel intensity values, stored in the form of pixel intensity for raster systems. This is place where image or picture are stored as an array, matrix of 0 and 1s. 0 represents darkness and 1 represent image. Frame buffer is the video RAM. It means VRAM that is used to hold or map the image display on the screen. A frame buffer is a large contiguous piece of memory. It means it is a piece of memory. Again, its block diagram: input devices, system bus, CPU, system memory, and frame buffer, video controller, and monitor. Write clearly. Now we have another video controller. What is this video controller? In figure, the basic refresh operation of the video controller are diagrammed. 2 registers. This diagram is here. Note that this diagram is here. We will learn it after this. Of the video controller are diagrammed. 2 registers are used to store the coordinates of the screen pixels. As we know, every pixel have values x and y. 2 values. So for this purpose, we have 2 registers, x for x values and y for y values, means vertical values. The value stored in the frame buffer for this pixel position is then retrieved and used to set the intensity of the CRT beam. Then the x register is incremented by 1. This procedure is repeated for each pixel along the scan line. Now check this. This is that process. Frame buffer, we have frame buffer, pixel register, this is for intensity, memory address, and for this memory address, we have 2 registers, x register and y register. Raster scan generator, as we have learned, horizontal and vertical voltages. This is the basic video control refresh operation, as we are seeing. Mention this in your notebook and complete your work. Thank you.